Third part of the series of probability, this is addition law of probability. What does it state? The probability of an event A or an event B is basically, in mathematical terms, probability of the first event plus probability of the second event. So this is called unconditional probability. Let's try to understand it with the help of an example. A card is drawn at random. Find from a pack of 52 cards, these cards that are shown over here. Find the probability that the card is an ace or a king. To ace, how many aces do we have over here? We have 1, 2, 3, 4. How many kings do we have over here? We have 1, 2, 3, 4. What is the chance of drawing an ace? Ace over here is going to be probability of the first event. King over here is going to be the probability of the second event. So basically, how many aces do we have? 4. 4 by 52. How many kings do we have? 4. Once again, plus 4 by 52. So the answer is going to look like this. Probability of an ace or a king, or the conjunction or should transform into a plus sign. That is what you need to know. Take a look over here at the pink arrow. Wherever you see or, it should translate into a plus sign to 8 by 52. Alright. Second part says a heart or a diamond. How many hearts do we have over here? There are 4 types of cards, right? We've got clubs, spades, hearts and diamonds. We've got 13 hearts. And how many diamonds do we have? 13 again. So heart or a diamond is 13 by 52 because that represents hearts. A plus because it says or 13 by 52 because 13 by 52 represents the probability or the chance of getting a diamond. That adds up to 26 by 52. Obviously you can simplify these numbers by 2 and get a simplified answer. You can also simplify this number by 2 or just follow the table of 26. How many 26s fit into 52? 2, so it's 1 over 2. Or you can always leave the answer like this as well. The third part says neither a king nor a queen. So we should not get king, or we should not pull out a queen out of a deck of 52 cards. One way to do it is just add up all of these. Let me choose a thicker marker. One way to do is add up all the rest, or find out the probability of king and or a queen and then subtract it. So let's see. The first method is neither a king nor a queen. I'll stick with this. I'll go with the second method first, which is the observation. Just like I told you, basically you do not need king. Neither the king nor a queen basically means you do not need either of these. If you cross them out, how many are left? Count them up. You're left with 44 divided by 52. But Cambridge requires you to know the other method as well, which is subtracting 1. Subtracting the other probability from 1 and getting the answer preferred or required answer. The required answer is probability of neither getting a king nor a queen. So what you should do is find out the probability of getting a king or a queen. How many kings or queens do we have over here combined? There are 8, 4 kings and 4 queens. So what we're going to do is add them up. 4 kings and 4 queens. That becomes 8 out of 52. Now we do not need them. Subtract them from 1. Subtract them from 1. 1 minus 8 by 52. And you'll notice, by the way, I took LCM over here. This has 1 underneath it. So 1, what do I multiply 1 way to make it 52? Why? Because the LCM is supposed to be 52, right? I multiplied with 52 in the numerator and denominator because whatever you do in the denominator, you have to do the same thing in the numerator. 52 minus 8 over 52, that gives us 44 over 52. If you notice, that is the exact same answer that we got over here. That is addition law of probability for you all. Multiplication law of probability, what does it state? Whenever you have the conjunction or you use plus sign, remember? But whenever you have the conjunction and you use multiply, and that's what the pink arrow tells you over here. Once again, let's try to understand it with the help of an example. A marble is picked random from this bag, which you can see. Red, green and yellow marbles are there in the bag. Find the probability that the first marble drawn is yellow. You will have a very plain and specific condition that the first marble or the only marble that you pick out should be yellow. There are 3 in total. What's the chance that you will select a yellow marble? That's 1 by 3. Simple. And that's your answer down here. Probability of yellow is equals to 1 by 3. It starts getting tricky by the second part. The first marble drawn is green and the second marble drawn is yellow. the chance that you will select the first one and it will be green is 1 by 3. And once it's gone, how many are you left with? So do not consider this for a second. This is gone. Now how many are you left with? 2. What is the chance of now selecting a yellow? Read the second part of the question. Once this marble is gone, the question says second marble drawn is yellow. So once this green marble is gone and it's outside the bag like this, what's the chance that you will select a yellow now? The chance now that you select a yellow is 1 by 2. And the question, since the question had the conjunction and, you'll multiply. This and transforms into a multiply sign, so the answer comes out to be 1 by 6. Now on a probability scale, how much is 1 by 6? If I were to divide 1 with 6, I will get 0.166. Or basically that's 16%, 16.66. However, the answer for the previous part was 1 by 3. That was, if I'm not wrong, 0.333. And if I were to convert that into percentage, that's 33%. 33.33%. Now, why did the probability drop so much? The first answer for part 1 was up here, and the answer for part 2 is down here, very close to 0. The reason for that is, since you add more and more conditions, the probability that the scenario or the scene would play out exactly as you want it to be, the chances drop for that. So jitne zyada conditions utne chances come. For instance, in a hall of people, you're looking for people who are tall and who happen to be rich. So basically, if there are 100 people in a hall, 85% of them are short, or what you would consider short, and only 15% are tall. Now out of those 15%, only 2% happen to be rich as well. So when you put in two conditions, the probability that, or the chance of that particular thing happening becomes very narrow, right? So that is why probability is dropping in this case. So probability of getting a green ball and then getting a yellow ball is pretty low. Now let's reset this question. Give me a minute. In fact, why don't you read the second part while I fix this question? Sorry, the third part. The first marble drawn is red. So let's take this back over here and let's make this green again. So the question says the first marble drawn is red, right? And the second is green. So this green marble should come out at the second turn, and the first turn should give us the red marble. So what are the chances of that happening? The first marble drawn is red. Once again, the probability of getting the first one as red is 1 by 3. So we will write that down and multiply. And the second, wait, hold on. Sorry, the first one is red. The first one is red is 1 by 3, and the second one is green, 1 by 2. Similar to the one that we just did, only the colors are different. And the answer, if you notice, also happens to be exactly same as the previous part, that is 1 by 6. Remember, this is why it's called conditional probability, because once you pull out a ball or a marble from the bag, the total number of marbles that are left in the bag are different now. Pehle 3 the, there were 3 at the start. Once you pull one out, there are only 2 left for the second draw. So that's why the denominator drops by 1 number. Okay? And for the conjunction or and you're supposed to multiply. Now the trickiest part is where they stop using the words first and second and just says one and the other. One marble drawn is red and the other is green. So they're basically not giving you a particular order in which the marbles should be pulled out or drawn. So one marble is red. So what if you say the first marble that I draw out is red and the second marble that I draw out is green, or we put all of those marbles back in. What if we pull out the first one as green and the second one comes out to be red. That's also a possibility, right? Because they did not ask us if the first should be red or the first should be green. They're saying just one should be green, one should be red. Both of these conditions are possible. So what's the possibility or probability of you selecting the first marble as red? 1 by 3. And means multiply. We discussed that numerous times. The second one, remember, I'll even draw this over here. Don't forget, once we're selecting the second, first one is gone, red is gone. What are the chances of you selecting a green now? 1 out of a total of 2, because red is gone. So that's 1 by 2, right? And let me fix this multiply sign as well. Or means plus. We're going to add up the second set of probabilities now. Now what is the chance of you selecting? A question has been reset, the balls have been put back into the bag. What is the chance? That's the scenario that we're coming up with, because that's another possibility. So we're resetting the question ourselves. The question doesn't ask us to, but the answer would not be correct if you do not reset the question. Now, what is the probability of selecting a green marble? Let me erase this. What is the probability of selecting this green marble? The arrow that you see now, 1 by 3. We will write that down over here. And means multiply. Once the green marble is gone, let me throw it out. Right? Now what is the probability of selecting red marble? There are only 2 left in the bag. One of them is red. 1 by 2. So let me put that back. 1 by 2. So 1 by 6 plus 1 by 6, that gives us 2 by 6. That's your answer for the last part. I hope it made sense. We discussed the idea of and, wherever you see and, you're going to use multiply. Wherever you see or, you're going to use add. And this is why it's called conditional probability, because once you select a certain item, it has an effect. Once the condition has been fulfilled, it has an effect on the possibility or probability of selecting the second item or the second marble. So it has an effect on the second drop. So this is all for multiplication law of probability, but once again, this is not enough. We will have to do past paper questions in order to completely understand the type of questions that do come up in your CIEs. Hope it helped. Khuda Hafiz and take care.